Hello, this is Lab 3, Analysis of a Black Hole. The purpose of this lab was to utilize Newton's second law and the law of universal gravitation to discover the unknown mass of a black hole, given known variables, as well as the motion data of an orbiting star. The main physics ideas in this lab were Newton's second law, or the momentum principle, which states that the net force is equal to the change in momentum over the change in time, as well as the law of universal gravitation, which states that the force of gravity is equal to g, a gravitational constant, times the two masses of the objects divided by the distance between the objects squared. Our assumptions for this lab were that 1. The force of gravity on the star by the black hole is the only component of net force on the star and therefore on the system. And 2. The duration of the analysis was 1 Earth day, or 86,400 seconds. I successfully found the mass of the black hole to be 3.6099 times 10 to the 31 kilograms. I utilized the code to calculate FNet, FNet parallel, and FNet perpendicular. To find FNet, the code first took the motion data and broke down the position vectors, subtracted position vectors from one another to get velocities. These velocities could then be subtracted to get changes in velocities. The change in velocity could be multiplied times mass divided by the change in time to get dp over dt, approximating the net force. This process was repeated for each position value until the very last point. To find FNet parallel, I utilized an equation which states that dp dt parallel is equal to the magnitude of the final momentum minus the magnitude of the initial momentum divided by the change in time times p hat, a unit vector. I couldn't use a similar equation for FNet perpendicular due to our limitation of variables. So I found dp dt perpendicular to equal dp dt minus dp dt parallel, since dp dt parallel plus dp dt perpendicular equal dp dt. I edited a few things on the code, specifically in the calculation loop, where I edited equations for velocity, momentum, net force, and dp dt, both parallel and perpendicular, to match Newton's second law and the momentum principle. I also printed off the magnitude of the net force, which I'll use for my mass calculation, as well as the final star position, which I can also use for the calculation. Here's the code. As we can see, there are 3 arrows. The yellow arrow represents the net force, the blue arrow represents the perpendicular net force, and the black arrow represents the parallel net force. So we get the overall net force, 1.0272 e to the 27th, which we'll use in our calculation. Using the original equation for the universal law of gravitation, we can isolate for the mass of the black hole. And what we get is that the mass of the black hole is equal to the gravitational force times the distance squared divided by constant g times the mass of the star. I found the position vector r by subtracting the position of the black hole from the position of the star in its final position. I then took each vector component, squared it, added the two components together, and then found the square root of the whole thing to get the distance. I squared this distance to get the r squared that is used in the equation. Since the force of gravity is the only force in the system, we can say that it's equal to the net force, which allows us to find the mass directly. And when we plug in all of our variables, we get that the mass of the black hole is equal to 3.60986 times 10 to the 31 kilograms. By doing dimensional analysis, I was able to determine that the correct unit is there for the mass, because we're left with just a single kilogram. For the what if and what does it mean questions, the what if question first, we are unable to find a new black hole mass if both the mass and the motion of the star are unchanged. These two things remaining constant implies that the force of the black hole on the star would also remain the same. Since this is the only force that we know of in the system, the mass would be unable to change and would have to be the same. For the what does it mean question, FNet in both its perpendicular, parallel, and regular components shared the same units as dp/dt perp, dp/dt parallel, and dp/dt, in that they're both kilograms times meter over second squared. However, FNet and dp/dt are utilized in different situations initially. FNet is utilized initially for situations where there is no available motion data, as in our previous two labs, whereas dp/dt is utilized initially for situations where motion data is already available, such as we had in this lab. we can find both dp/dt and fnet respectively, regardless of which one we have initially. However, the difference between the two is found in which situation they are readily available in. Thanks for watching.